Chapter 10 focuses on conics. So we're going to look at conic sections. We're going to look at the different types of them and then the equations that would produce them. So a double napped cone is pictured here in blue, and planes are pictured here in pink. So the four possibilities of intersections of double napped cones and planes are as follows. You can have a circle, you can have an ellipse, a parabola, or a hyperbola. We're going to go through each of these and look at the equation that would produce them. First, we'll start with parabolas. The parabolas that we'll look at are one of two forms. You'll notice the first form starts with y equals, and the x variable will be squared. That's going to be a parabola that you will typically have seen in previous courses that opens up or down. The other one we'll look at is not a function, but it is a parabola. It starts with x, and the y variable is squared. That's going to open right or left. So we'll look at each of these and then do an example. The first one, the top box here, y equals a, quantity x minus h squared plus k. The vertex would be h, k. So you get your vertex by taking the number in the parentheses with the x and taking the opposite of it. So the standard form is minus h in the parentheses. So we're going to take h, which is the opposite of negative h, and then the number that is added or subtracted after the parentheses will be the second number of the vertex, and that is k. If a is greater than 0, which is positive, you'll have a parabola opening up. If it's less than 0 or negative, you'll have a parabola opening down. We'll do an example here with that form. The second rectangle is if it starts with x equals and the y variable is squared, your vertex is going to be similar, but you're going to take the numbers in the opposite order. So you'll start with k, and then second is h. So you still get them from the same h and k, you just flip them, k, h. If a is positive, instead of opening up, when you have this format here below, it's going to open to the right. So if you can picture that, it'll be a parabola opening sideways to the right. If a is negative, it will be opening to the left. So that would be like open to the left. So let's look at a couple of examples of these. The first one, like I said, is more one that you've maybe studied before in other algebra classes. So this may be, more of a review for you. We're looking at the vertex here is hk. H is 2 and k is 1. So it'd be 2, 1. And since a is positive, a is 3, we're going to be opening up. So I'll start with my vertex. I'm going to graph this. It is over 2, up 1. That's my vertex. And then it's opening up. To get my points accurately going up, I'm going to look at a vertical stretch of 3. So from my vertex, I'll go over 1, up 3. Back to my vertex, I go back 1, up 3. It gives me that symmetry about the vertex. Next up, example 2 is the other format. So if you look here, h is negative 4. It's opposite of the sign that it shows there. And k is 3. So when I do my vertex, first I take the k, and second I take the h. So it'd be 3, negative 4 is my vertex. And then a here is negative 1 due to this negative out here. And so I'm going to be looking at it opening left. So I'll plot my vertex, 3, negative 4. And then my a is negative 1. I open left, so I'm going to go up 1, over 1, down 1, over 1. And that is my parabola opening left. All right, moving on. Circles, here are the two formats that we'll see for circles. They're the same. I just have one that has a specific center. So we'll look at the top one first. The center is going to be HK. You'll take the H and K from the numbers in the parentheses with the X and Y. And the radius is R. You'll see over here in standard form, it's R squared, so it's going to be a radius squared. So you will have to square root that to get the radius. If there are no parentheses, then your center specifically would be at 0, 0. There's just no numbers being added or subtracted from the X or the Y. And similarly, your radius would be R. So if we look at an example here, my H is 2 and my K is -3. Remember, in the parentheses, you'll take the negative version of those numbers, or the opposite, I should say. So here my center is 2, -3, and my R is going to be square root of 1, which is 1. So my center is 2, -3, and my radius is 1. When I graph that, I'll go over 1, up 1, over 1, up 1, or down 1, so that I have 4 points on the circle that are 1 away from the center. And I like to draw in a radius and label that. So R is 1. Ellipses will be similar to a circle, but they're going to have a more oval shape. So you can see the, I put it in here for you, you can see the standard form here. Similarly to a circle, we will get our center from H and K. It's just here, the standard form always equals 1, so you don't get a radius from there. You are going to get not a radius because it's not a circle, but you'll get a distance from the center to the edge from taking the square root of a squared. So this will be distance from the center to the left edge of the oval and then center to the right edge of the oval. If you look at your b squared, you'll square root that, and b is the distance from the center to the top edge and the bottom edge. All right, so let's take a look at an example. Here, I'll get my center like I did from my circle. Opposite of -1 will be +1. Opposite of -2 will be +2. So my center is going to be 1, 2. Then I'll look at the 4. That is a squared, so that means a is 2. And I look at the 9. That is b squared, so b is 3. Those are my distances from the center to the edges. So I'll take my center, 1, 2. A is the distance from the center to the edge. So that's my A equals 2. And then B is centered to the top and the bottom. So 1, 2, 3. And if you connect these 4 outer points, that is your ellipse. A is 2 and B is 3.